So on behalf of Rohini College of Engineering and Technology, myself Justin Leo, Assistant Professor, Department of Mechanical Engineering, welcome you all for this video session, Basic Civil and Mechanical Engineering course, and the course code is PE8252 for the regulation 2017. So in this video session, we'll be studying about the vapor absorption refrigeration system in Unit 5, Refrigeration and Air Conditioning. So there are some objectives on studying this course. So the first objective is to impart basic knowledge on civil and mechanical engineering and to familiarize the materials and measurement used in civil engineering and to provide the exposure on the fundamental elements of civil engineering structures. And the final objective is to enable the students to distinguish the components and working principle of power plant units, IC engines, and refrigeration and air conditioning systems. And these are all the syllabus. So for the 5th unit, that is refrigeration and air conditioning system, terminology of refrigeration and air conditioning, and the principle of vapor compression and absorption system. And in this video session, we'll be studying about this vapor absorption system and layout of typical domestic refrigerator, window and split type room air conditioner. So these are all the textbooks and reference books for the course Basic Civil and Mechanical Engineering. So the course outcomes. The students, after completion of this course Basic Civil and Mechanical Engineering, they will be able to experiment with a typical domestic refrigerator and different types of room air conditioner upon completion of this final 5th unit of this course. And before we go in depth with this vapor absorption refrigeration system, we'll just go study about what is refrigeration. So refrigeration is nothing but a process of providing and maintaining a temperature which is just well below that of the surrounding atmosphere. So you can say it in other words, refrigeration is nothing but is a process of cooling substance. So refrigerators and heat pumps. So you can see here from this diagram. So this is a heat pump. So the main purpose of the machine is to cool some object. So the machine is named as the refrigerator. This is the refrigerator. Okay. So it's a refrigerator. The purpose of this refrigerator is to cool the space. That is the object, right? So the heat pump, and the main purpose of this machine is to heat a medium to make the space warm than the surroundings. So this machine is termed as the heat pump. So coming to this vapor compression refrigeration system. So this vapor compression refrigeration system, the compression process of vapor compression cycle is eliminated here. Instead of that, you have these following processes. That is absorbing ammonia vapor into water, pumping a solution to high pressure cycle, and producing ammonia vapors from ammonia solution by heating. So these are all the components. And this is the layout of this vapor absorption refrigeration system. And you can see here you have an evaporator here, and from absorber unit, and you have a liquid pump here, and you have pressure reducing valve, heat exchangers, generator in which you have this analyzer, and you have the heating coil in this generator, and you have this rectifier unit in which the cold water is circulated, and you have the condenser unit in which the cooling water is being circulated here. You have the liquid reservoir, and you have a throttle valve, and this layout shows the vapor absorption refrigeration system. So coming to the construction, And you can see here this animated view of this vapor absorption refrigeration system. And here this vapor absorption system consists of a condenser unit. This is a condenser unit, and it has an expansion valve, and it has an evaporator unit. So these units perform same as that what they do in the vapor compression refrigeration system. So in addition of these components, this system has an absorber unit. Here you can see this absorber unit, and it has a heat exchanger as well as analyzer and a rectifier unit. So these are all the additional components apart from this condenser, expansion valve, and evaporator unit. So coming to the working of this absorption refrigeration system, so you can see here, dry ammonia vapor at low pressure passes into the absorber. So you have this absorber here, and here you have the evaporator. So what happens is the dry ammonia vapor will be present in this absorber as a low pressure, and that is passed as the form of vapor to this absorber. So in this absorber, this dry ammonia vapor is dissolved in cold water, and a strong solution of ammonia is formed here. And the heat evolved during absorption of ammonia is removed by circulating cold water through this coil. You can see here you have this coils through which the cold water circulated, that is in the absorber. So this highly concentrated ammonia, which is known as aqua ammonia, then it is pumped out by the pump to the generator unit. So this is a generator setup through a heat exchanger. So there is a heat exchanger also here. So in this heat exchanger, what happens is this strong ammonia solution is heated up by the hot weak solution, which is returning from the generator. So it's a weak solution, hot weak solution returning from the generator. So that is used to heat this strong ammonia solution. And in this generator, this warm solution is further again heated by the coils here, heating coils, steam coils, by gas or electricity, and this ammonia vapor is now driven out of solution. And this the boiling point of this ammonia is less than that of the water. So what happens is this vapor leaving this generator are mainly of ammonia. And what this weak ammonia solution is left in this generator, and that is called weak aqua. So this weak aqua solution is returned to the absorber unit. So this weak solution, that is called the weak aqua, is returned to the absorber unit. You can see this dotted arrows through this pressure reducing valve. Okay, and the ammonia vapors leaving the generator may contain some water vapor, and if this water vapor is allowed to the condenser and the expansion valve, it might freeze, resulting in the choked flow. So analyzer and rectifier are incorporated in the system. So you have this analyzer here and the rectifier unit in the system before this condenser unit. So now the ammonia vapor from the generator passes through a series of trays in the analyzer unit, and here the ammonia is separated from the water vapor, and this separated water from this ammonia vapor is returned to the generator, and the ammonia vapor passes through the rectifier. You can see here the rectifier, which is cooled by the cooling water. So this rectifier resembles a condenser, and the water vapor still present in ammonia vapor gets condensed, and this condensate is returned to the analyzer again. So the virtually pure ammonia vapor is then passed through the condenser. So the condenser unit receives only pure ammonia. So now the latent heat of ammonia vapor is rejected by the cooling water circulated in the condenser, and the ammonia vapor is condensed, and once it is condensed, it forms the liquid ammonia. So now this high pressure liquid ammonia is throttled by an expansion valve or a throttle valve. Here you can see a throttle valve. So this reduces the high temperature of the liquid ammonia to a low value, and this liquid ammonia partly evaporates. So then this is led to the evaporator. And again in the evaporator, the liquid fully vaporizes, and the latent heat of evaporation is obtained from the brine or other body which is being cooled here in this evaporator. So now what happens is the low pressure ammonia vapor leaving the evaporator would enter the absorber, and the cycle is completed. So this forms one cycle, and again the cycle is repeated to provide a refrigerating effect. So this is what about vapor absorption refrigeration system is. So coming to the applications of refrigeration system, it is used for preservation of food items like vegetables, milk and eggs, preservation of medicines, used for preservation of blood, tissues, etc. It is used for preservation and cooling of cool drinks, and the refrigeration system is used for preservation of chemicals in chemical industries, used in cooling of water, and it is used in industrial and comfort air conditioning system, and also used for processing of dairy products. So comparison of vapor compression and vapor absorption refrigeration system. So first is the vapor compression system. So this system has more wear and tear, and also produce more noise because of the moving part of the compressor. And the vapor absorption system, here the moving part is only the aqua pump, hence quieter in operation, and hence less wear and tear. And coming to the vapor compression system, the second point, electrical power is needed here to drive the compressor unit. And here, vapor absorption system, waste of exhaust steam is used, so no need of electric power here. And here, the vapor compression system, capacity of the system normally drops rapidly with the lowered evaporator pressure. Whereas here in vapor absorption system, the capacity of the system decreases with the lowered evaporative pressure by increasing the steam pressure in generator. And the vapor compression system, you have at partial load performance is poor, and here at partial loads performance is not affected. And vapor compression system, mechanical energy is supplied through compressor, whereas in vapor absorption system, heat energy is used. And in vapor compression system, energy supplied is 1/4 to 1/2 half of the refrigerating effect. And here the vapor absorption system, the energy supplied is about 1.5 times the refrigeration effect. And the vapor compression system, charging of refrigerating to the system is easy, whereas the vapor absorption system is very difficult. And in vapor compression system, preventive measures is needed because the liquid refrigerant accumulated in the cylinder may damage to the cylinder. And here vapor absorption system, the liquid refrigerant has no bad effect on the system. So with this, we come to an end with this video session of the 5th unit. So thank you and have a